So in this question, we have three parts, right? The first part is that we need to prove the three-dimensional virial theorem, right? Now, let's start with the solution. Now, we know that the virial theorem, right, it gives us a relation or an equation that that explains us the relationship between the expectational value of kinetic energy and the expectational value of value of the potential energy or potential of the system, right? So we can write it in the form of equation that the expectation value of the kinetic energy T, right? It is 2 times the expectation value of the kinetic energy is equal to the expectation value of R times del V, right? Um, Now this del V, it can be written as del partial derivative or del V divided by del R, right? So now how are we going to solve it? So for solving it or for proving it, we are going to use the Ehrenfest theorem, right? So Ehrenfest theorem, right, that states that the expectation value, the time derivative of some operator q, right? So time derivative of some operator q, right? So the expectation value of q is equal to I divided by h cross expectational value of the commutator of the Hamiltonian of the system and of the operator q, right? So plus expectation value of time derivative of q, right? So now over here we have q is equal to r times p, right? And when we will substitute it back over here, and as you can see that there is no explicit time dependence present in this equation, so it means that it would be equal to 0, so we would be only left with this term, right? So we can rewrite it as d by dt expectation value of r times p is equal to I divided by h cross commutator expectation value of commutator h and r dot p, right? So now we need to find out the value of h, right? So now this h, it can be written as the sum of the kinetic energy plus the potential of the system, right? And the kinetic energy for any system, it is simply p squared divided by 2 times m plus v, right? And it means that its commutator, right, it would be h r p is equal to summation or sigma 3. Now why 3? Because it's a 3 um, dimensional virial theorem that we are trying to prove, right? So 3 for that purpose, and I is equal to 1 because we would be starting from 1. Commutator Hamiltonian, Ri Pi. Okay, so next we are going to solve by using the basic commutator techniques and basic commutator arithmetics. Fine. So before starting it, let's look at some points that you must remember because they will come in handy, right? So commutator A, B, comma C is equal to A, C, B plus A, B, comma C. Fine. And the second thing that you must know, let's say that this is one, right? Is that commutator A comma B C is equal to A comma B C plus B commutator A comma C. Let's say that this is equation 2, right? Another thing that you must know is that commutator Ri comma Pi is equal to IH cross um, IJ, right? So let's say that this is 3. And the last thing that is important for you to remember is that V comma Pi commutator V comma Pi is equal to I H cross or the Planck constant partial derivative of V with respect to R sub I, right? So let's say that this is equation 4, and let's come towards solving our question from this equation onwards, right? So let's start it. Now summation 3I is equal to 1. We have p square divided by 2m plus v comma r I pi plus commutator p square divided by 2m plus v comma pi, right? So now what we have done over here is that we have used this value of age, right, for this equation, and then we have written it in this form, right? And we have used the simple commutator techniques as shown over here in equation 1 and equation 2, right? So we have just used those equations, and again we would be solving those equations till the point we get our end result. um, what I'm going to do over here is that I'm going to write a much simplified form of this equation because I have already told you about the equations or the commutator techniques that I would be using, so you can use them as well. There's very simple basic arithmetic, commutator arithmetics, and you can just use that. So keep on solving it, and you would get that summation 3I is equal to 1 divided by 2m summation 3j is equal to 1 negative I h cross p sub I p sub j I j negative I h cross p j p I j plus, since I'm running out of space over here, so I'm going to write the last term in the next line. Ri commutator V rho, sorry, not rho, it's p sub I, right? So now this equation would become, again using the simple techniques, right? So it would become 3I is equal to 1, negative 1, negative m I times h cross p sub j p sub I plus I sub r sub I parenthesis I times h cross partial derivative of v with respect to r sub I. So what we are going to do over here is that from equation um, 3 and 4 that I told you before the before the start of this question, right? From these equations, right, I am going to simplify this equation into the form I times h cross negative p square divided by m plus r times del v, right? Now this can be written as the commutator of the Hamiltonian r times p, right? Which was originally at the beginning of the equation when we started solving, right? So this is its value, right? Um, so it means that the Ehrenfest theorem that d divided by dt, right? The derivative of time derivative of the operator q that was actually r dot p, right? It is commutator negative r times del v plus p square divided by m, right? Not commutator, this was already the expectational value, right? And we can write it as d divided by dt r dot p is equal to 2 times the kinetic energy negative r times del v, right? And for the stationary states, right, we have this term equal to 0, right? So this would become 0 is equal to 2t negative r dot del v, right? And when we would rearrange it, we would get 2 expectational value of kinetic energy is equal to expectational value of r del v, right? Which is the virial theorem, and we were required to prove. So this is the solution for part A. Next, we need to solve part B, right? So that is that we need to apply the virial theorem to the case of hydrogen and show that the expectational value of T is equal to negative E sub n, right? And the expectational value of V is equal to 2 times E sub n, right? We need to show this thing. So for that, one hydrogen atom, we have V of R is equal to negative E square divided by 4 pi epsilon naught R, right? And for del V, this equation would become positive E square divided by 4 pi epsilon naught R square, R unit vector, right? So now what we are going to do over here is that we are going to multiply r times del v, right? So this is e square divided by 4 pi epsilon naught r, that is equal to negative v, right? And this implies that 2 times the kinetic energy, that is basically the virial theorem's left hand side, it is equal to negative times the expectation value of v, that is the potential of the system. But right, we know that expectation value of kinetic energy plus expectation value of the potential of the system is equal to E sub n, right? So from here we conclude, or we can get that expectation value of t negative 2 times expectation value of t is equal to negative the expectation value of 2, that is equal to E sub n, right? And from here we would get the value expectation value of t to be equal to negative E sub n, right? And the other thing would be the expectation value of v to be equal to 2 times the exponential value of E sub n, right? So these are the two values. So this was the solution for part B, right? And the next part that we are required to solve is part C, in which it asks us to apply the virial theorem to the three-dimensional harmonic oscillator and show that expectation value of the kinetic energy is equal to the expectation value of potential, that is equal to E sub n divided by 2, right? So let's start with it. Now we know that the harmonic oscillator's potential is equal to 3D harmonic oscillator's potential is equal to V is equal to 1 divided by 2 m omega square r square, right? And in this case, del V would be equal to m times omega square r unit vector, right? So it means that r times del V would be m omega square r square. So that means it would be equal to 2v, right? It is very clear from this, from this as well as this equation, right? So it's very clear that we would get the r times del v to be equal to 2v, right? So now we need to show that potential value of expectation value of the kinetic energy is equal to the expectation value of potential. So 2 times the expectation value of kinetic energy would be equal to 2 times the expectation value of v, right? And so it means that the expectation value of the kinetic energy would be equal to the expectation value of the potential energy, right? So but we have that the sum of the expectation value of kinetic energy and potential is equal to E sub n, right? And since kinetic energy is equal to the potential, so we can substitute over here and we would get that T plus T is equal to E sub n, and that means it would be 2 times the expectation value of kinetic energy is equal to E sub n, right? And we would get expectation value of T is equal to expectation value of potential is equal to E sub n divided by 2, right? So again, it was very simple. We have just manipulated, arithmetically manipulated uh, the given information, and right, we got our solution.